My name is Aaron Balke. I am the developer of the Guac emulator, a Game Boy Advance, and soon-to-be DS emulator. In the process of building out the DS emulation, it became necessary to build a JIT compiler, and today I'm excited to announce my revival and fork of GoJIT, a JIT compiler for Golang. In most programs, you have ahead-of-time compilation, which is you build out a exe or a binary inside C, Zig, Go, and then all of the instructions that get called during the program's runtime are inside that binary or executable. JIT compilation, on the other hand, allows at runtime new instructions to be built out, and then the program will jump to those new instructions. For most situations, this is overly complicated and not necessary. However, for programs that require high performance and are heavily based on input files, it becomes a necessity. The two main places you see this are emulators, such as my Guac emulator, or you can imagine Dolphin, and then interpreters, such as Python or JavaScript. In these programs, there's constant analysis being done to see if certain blocks are being called very often, and if it meets certain thresholds, then blocks of tokens in interpreters or instructions in emulators will then be turned into JIT code. In the future, it will run the JIT code instead of the original native version. This is faster because instead of running conditional branches every time and decoding every time, you just decode instructions and run conditional branches once when the block is made into JIT code, and then you don't have to do that process every time you call it. If you extrapolate this out to thousands of times, tens, hundreds of thousands, millions of times, all of a sudden you're talking about a 2 to 5 times speed increase. And I did find in the Guac emulator with DS emulation that it led to a 2 to 4 times speed increase. Golang differs from low-level languages such as C, C++, and Zig in that it has a garbage collector and doesn't give you permission to do a lot of low-level memory management. In addition to that, it also has a very strict application binary interface. This is how at the assembly level that things are handled. So you can imagine that certain registers are used for arguments and results, and the stack frame has to be set up a very specific way for Go to use it. And to make things even funner, Go actually has two ABIs, ABI 0, which is the original ABI, and then ABI internal, which is the new version of the ABI, which is used internally by the Go programming language. The big difference between the two ABIs is that ABI 0 uses just the stack for arguments and results from functions, while ABI internal uses registers when it can, and this leads to a 5% speed increase. However, ABI 0 is still used by user-facing assembly code, and ABI internal is solely used by the language internally, as the name suggests. The strictness of the Go ABIs and the complication of JIT compilation is why JIT compilation in Golang has been so difficult up until this point, and why if you actually look through issues, the Go team specifically states it's not supported at all. The big thing that this JIT compiler fixes that other JIT compilers have not been able to fix is the issue of calling Golang functions from within JIT code. In the Guac emulator that I was working on, there would be JIT instructions that need to call out to emulated memory. You can imagine emulating a load or a store instruction requires connecting to the memory or I/O through read or write functions. And the ability to do this was not possible because Go requires such a strict ABI, and so it would not find correct things when running the garbage collector, it would not do stack growth properly, and it would crash the program. This JIT compiler is the first Go compiler to allow this to work in modern versions of Go. Long story short of how I was able to get it to work was by using nasty reflections, some nasty usage of assembly labels, using the differences between Go at compilation versus runtime. It's a very dirty usage of low-level stuff in Go. However, this JIT finally is able to make it run. The exciting part is now other emulators and interpreters can be written in Go. If you're interested in more details on how I was able to get it work, I have an entire write-up on my website. A massive thank you to Alex Shaiprov, who did a lot of research on this subject in older versions of Go pre 1.17. Keep an eye out for the new update for the Guac emulator, including DS emulation. Thank you for watching, and I hope you have a good one.